Good morning, Mr. Stat Sensei, Mr. Spensei, and this is a warm-up on the T distribution. And we're going to set up a hypothesis test. We're not going to do everything. We're not going to do the conditions, and we're not going to do the conclusion on it. So a steel supplier claims that their bars have elongation of 40% under a stress of 10 metric tons. This is probably important because this is our claim. A random sample of 12, so N equals 12. Was taken from a warehouse and the elongation measured in percent per 2 inches. The steel bar elongation is normally distributed. Okay, well, that we know is important when we actually talk about conditions. So here are our observed values. Is there evidence at a significance level of 0.05? So they're telling us right here that alpha equals 0.05 to demonstrate that the elongation for the steel bars was different than 40. That's a key word because whenever we see different, we know that our alternative is going to be not equal to. So our alternative hypothesis, that is. So we took a moment and we entered that data. We went into stat edit. See if I can lighten the screen up just a little bit. There we go. Went into stat edit and entered all that data in. Now, we're running a t-test. So we know that our formula is going to be T equals X bar minus mu S divided by the square root of N. And if I have all that data into my calculator, which I now do, I can go stat, calc, 1 var stat. And I find out that I have a sample mean of 37.5833, a sample standard deviation of 3.1754. We already know the sample size is 12, and we know that their claim is 40, so that is the population mean. One thing to point out, the fact that we're using the sample standard deviation, that's what makes this a t-test. Excuse me. The next thing we need to do is draw our picture. Well, our picture is always going to be centered on the mean, and our mean was 40. And because it's a not equal to, because they use the word different, when they use the word different, that makes it a two-tailed test. And it turns out that we have a 37.5833. So it's going to be below the population mean, but this is still a two-tailed test. However, that's going to play into account later. So we need to plug into that. So we're going to plug in 37.5833 for X bar and 40 for the mean, and then 3.1754 divided by the square root of our sample size, which is 12. Obviously, we're going to run a one sample t-test. And if you just write one sample t-test, I'm going to be good with that. But it's a one sample t-test for means because we're studying the means here. And all hypotheses are always expressed as mu equals. That's our null is always expressed as mu equals. In this case, mu equals the claim. And then the question is it actually different than the claim? So mu not equal to 40. So then we need to define our parameter, and our parameter is always going to start the same. Let mu equal the true population mean, and notice we just wrote that out. And then are we interested in? True mean percent elongation of steel bars. Cool. So I'm going to take a moment now. I'm going to go ahead and run this test. I'm going to go stat, test, t-test, and I have data highlighted. And it's an L1, and make sure not equal is selected. All right. So we get a negative t statistic. Now we have to be really careful about this one. And the reason we have to be careful when we go to write this up is because this is a not equal, it's a two-tail. And if it's a two-tail, we have to include 2 times in front. 2 times the probability that t is less than. And you're probably wondering, how did I know that this was less than? And there's a couple ways. One, my t statistic was negative. The other thing is my X bar up here was below the mean. So between being below the mean and or being negative, having a negative t statistic tells me that I'm going to have a less than symbol. But anytime we're using anytime we're using not equal or a two-tailed test, we need to have that 2 times out there. All right, we got a p-value of 0.0231. Our 0.0231 is less than our alpha of 0.05. So our decision is to reject the null. And by the way, if you missed out on what I had on my screen, my calculator screen, here it is. This is my X bar. This is my sample standard deviation. And there's my sample size. All right, I sure hope this helped and look forward to seeing you on the next one. Thank you.